Solving absolute value inequalities, part 2. In part 1, we looked at absolute value inequalities that were either less than or equal to. Now, in this part, we will look at the other two inequalities, which are greater than and greater than or equal to. Let's begin with an example. Example 1, solve absolute value of x greater than 7. To answer this question, I want to read the problem and notice that I'm looking for all those x's or all those numbers whose absolute value or distance from 0 is more than 7. So I want to think number line and mark 0 somewhere. If I go 7 units to the right, so if I go 7 in this direction, I will arrive at positive 7. And if I go 7 in this direction, I arrive at negative 7. So they're both 7 units. I'm looking for all those numbers whose distance is more than 7, which means I want to stay more than 7 units away from 0. So it would be all of these numbers that are more than 7 and they go all the way to infinity. So we show that using an arrow. And also notice if you go to the left of negative 7, there again you'll find numbers that are more than 7 units away from 0. So we have two separate intervals. What about the boundaries, 7 and negative 7? Can we include them? The question says we want absolute value of x to be strictly greater than 7. If I include 7, then it's not more than 7 units away from 0. It is 7 units. So I'm not going to include the boundaries. So if I don't have equality, then the boundaries are not included. So that's how I can picture my solution on the number line. Now, how do I write this using intervals? Okay, let's look at this part. This is saying x is greater than 7. So I want to look at the question where it says absolute of x greater than 7. The answer or the solution is simply x greater than 7 or, so to go from absolute values to the solution, I have two parts. The first part simply won't have the absolute value sign. It would be just x greater than 7 or x. Now this part is x less than negative 7. So greater than equality would have two separate intervals. One uses the same 7, the other uses negative 7. Now it's the same, you remove the absolute values and copy the rest of the inequality. So you say x greater than 7. But remember, you got to have one other solution, which is x less than negative 7. Now, how do you write this using interval notation? Well, let's write this part first. the left interval is negative infinity to negative 7, and the right interval is positive 7 to infinity. And since the boundaries are not included, I'm using parentheses. And then you don't say it's this and this or it's this plus this. When it comes to sets, you use this symbol U. It stands for union. You say that your solution is the union of this set and that set. All right, let's look at one other example. Example 2 is to solve absolute of y greater than or equal to 6. So to write down the solution, I'm going to have, so I can write down the solution the way I wrote here, or I can first graph it. This time I'm going to write down the solution first. So the solution consists of two parts. The first one would be y greater than or equal to 6. So simply remove the absolute values. That will give you one solution. That will give you one part of the solution. The other part would use the flipped inequality. So it would be y less than or equal to negative 6. So when you're using positive 6, it's greater than or equal to, or when it's negatives, when you're using negative, then it's less than or equal to. Now, whichever way you want to remember, it has two parts. And then how do you write this in the interval notation? We want to write the left part first and then the right part. So I want to write this one first. Y less than or equal to negative 6 is going to be negative infinity to negative 6. And this time it's actually 6 is included and so is negative 6. So it's going to be a closed bracket, and then y greater than or equal to 6 means it's going from 6 to infinity. But 6 is included in our answer. So this time we have brackets. And to graph, maybe I should have graphed first. That's what I'm going to do in rest of the examples. So this is 0, this is 6, that's negative 6. I have two separate intervals, one going to the right of 6, so more than 6, and the other going to the left of negative 6. And this time, since I'm including, I have equality, which means I'm looking for all those numbers whose distance is greater than or equal to 6. So or equal to. So even 6 is part of the solution, and so is negative 6. So if you don't see the equality, then it's going to be open circles on the number line on the graph, and it's going to be parentheses in the interval notation. If you see the equality sign, it's going to be brackets in the interval notation and closed circles in the graph. All right, let's try one more problem. Example 3, I'm going to say solve absolute of L is greater than or equal to 2. So if I want to write down the solution, I'm going to write two separate parts. So the solution is simply L greater than or equal to 2 or L less than or equal to negative 2. And let's graph them both. So this is 0, negative 2 is on the left of 0, positive 2 is on the right of 0. And I want to go more than 2, that's what this part is saying, or less than negative 2. So less means going left of negative 2. And the boundaries are included as well this time because we have the equality. And how do I write this? Using interval notation. It's going to be negative infinity to negative 2. And since negative 2 is part of the solution, it will be bracket here. And positive 2 to infinity is, again, there's a bracket at 2 union. Now, at negative infinity and positive infinity, we always leave parentheses. It's never going to be brackets at infinities. The bracket means that we have to include these numbers as well in the solution. And infinity is not a number, so that's why we just use parentheses at infinities. So keep that in mind. All right, let's look at one other example. Example 4. Now this time, I'm going to say solve absolute of x plus 5 is greater than or equal to 8. So in this problem, we have something more than just absolute value of x on this side of the inequality. So before we write down our solution, we need to get rid of the plus 5. We got to have just the absolute values on one side of the inequality, preferably on the left side. So to get rid of the 5, we subtract 5 from both sides. And then the new inequality you get is absolute of x plus 5 minus 5. Cancel each other out. So it's just absolute value on this side. And if I subtract 8 minus 5, I get 3. And subtracting 5 won't affect the inequality. Whatever inequality I had earlier, it would be the same. So now at this time, I can write down my solutions, or my solution, which is x greater than or equal to 3, or x less than or equal to negative 3. And then let's graph the solution on the number line. Draw the number line. It provides a great visual. And negative 3 will be on the left side of 0, positive 3 is on the right side. And then we want to go more than 3. So the first part says x greater than or equal to 3. So I'm going to shade everything to the right of 3, and it goes on forever. So I want to shade that arrow as well. And similarly, come to x less than or equal to negative 3. So it's going to be this interval. And now I think about the boundaries. Do I include the boundaries? Yes, because I have equalities. So that's the graph. And in interval notation, I'm going to have negative infinity. It's all the solutions are coming from negative infinity, and they go up to negative 3, including negative 3. So I'm going to use brackets. And then they start at 3 and includes 3. So I'm going to use brackets and go all the way to infinity. And how do you say that we want both of these? Is with this symbol u. So you say the solution is negative infinity to negative 3 closed, union closed interval 3 to infinity. All right. So that's what you do when you don't have just the absolute value. You have to go a step further. Now, in example 5, I want to say 4 times absolute of y is greater than or equal to 20. So just like example 4, I don't have just absolute value on one side of the inequality. I need to get rid of this 4 first. So how do I do that? I divide both sides by 4. So again, if I divide both sides by 4, what happens on the left is the 4's cancel each other out, leaving me with absolute of y alone. And on the right, 20 divided by 4 is 5. And if I divide by positive number like 4, it does not affect the inequality. So whatever inequality I had earlier, greater than or equal to, will remain the same. Now, I have only absolute value inequality on this side, absolute value on left side of the inequality. So at this point, I can write down my solution. So it has two parts. The first is y is greater than or equal to 5, and the second is y less than or equal to negative 5. So be sure to write both parts and then graph them. Graph your solution. So mark 0 somewhere on the number line. Then negative 5 is 5 units to the left of 0. So you can pick some point and say this is 5 units. And try to do your best to keep these two distances the same, because they are same. And now you want to go to the right of 5, and it includes 5 as well. So if I'm going to have a solid boundary, it goes on forever to the right of 5, and it's less than or equal to negative 5. So I want to start at negative 5, including negative 5. So if I'm including the boundary, then it's going to be a solid circle, and I go to the left of negative 5 forever, which means I need an arrow. And in the interval notation, this would be negative infinity to negative 5. Now, one mistake is to write negative 5 to infinity. No, you always want to start at the left and stop at the right. And is negative 5 included? Of course, yes. And then 5 to infinity. 5 is included in the graph. 5 to infinity. And I want to use the symbol U for union. All right, so this is what I have for example 5. Now let's challenge ourselves a little bit more. By throwing in some more complications. So sometimes you may have absolute of x minus 3 is greater than 5. So you have just the absolute value on the left side of the inequality. So you're ready to write down the solution. But it's not just x, it has something more than x. It does not matter. As long as you have just the absolute value, you can write down the two parts of your solution simply by removing the absolute value first for the first part, or you want to use the same expression, x minus 3 less than negative 5. So whatever expression you have within the absolute value is either greater than 5 or less than negative 5. Now we have to go a step further because we have not solved for x. We need to get rid of the negative 3. So let's add 3 on both sides. And then we get x, and 5 plus 3 is 8. If I add 3, it's not going to affect the inequality, so it's still greater than. Now I come to the second part. Here also I have x minus 3, which means I'll be adding 3 on both sides. And solve. It's going to be x less than negative 5 plus 3 is negative 2. So there are my different parts of the solution. On the number line, how does that look? So say I have 0 somewhere here, and it's x greater than 8. So 8 means I got to go 8 units to the right of 0. So I want to say this is 8. And then I also need negative 2 on the number line. So if this is 8, negative 2 might look something like this. Yeah, negative 2 is closer to 0. 8 is far away. And now this time I need to go x is more than 8. So it's going to be greater than 8. And notice this time the boundary is not included. So I will leave the boundary open circle. And the other part is x less than negative 2. So you want to start at negative 2 and go to the left. So that's your graph. And this time you want to write the inequalities. Inequality says start at negative infinity and go all the way to negative 2, but don't include negative 2. So parentheses. So remember, you're not saying that you want to start at negative 2 and go to negative infinity when you're using interval. Interval always means the left endpoint should be first and then the right endpoint. So you say that you start at negative infinity and go to negative 2. Now for this, you start at 8 and go to infinity. Usually students don't make a mistake there, but I've seen several times that students write this interval incorrectly. They would write negative 2 first and then negative infinity. But remember, you always want to have negative infinity first. And all right, let's look at example 7. How about if I have something like, say, 5 minus m is greater than or equal to 2. The first thing I realize is I have just the absolute value on the left side of the inequality. So I'm ready to write down my solution for this expression. It's not going to be solving for the variable right away, but I can get the first step. 5 minus m is greater than or equal to 2, or 5 minus m is less than or equal to negative 2. Now I got to solve for m, which means I will get rid of this 5 first because that's a separate term. So to get rid of 5, I got to subtract 5 from both sides, and let's write down. So on the left, 5 minus 5, they cancel each other out. Don't forget there is a minus in front of m, which means I'm going to have negative m, and 2 minus 5 is negative 3. Now if I subtract 5 from both sides of an inequality, it's not going to affect it. which means the inequality is still greater than or equal to. And now I got to go a step further because I got to get rid of the negative one. So let me copy that inequality first. And then how do I get rid of negative in front of m? You can say that you can divide both sides by negative 1. So let's go ahead and do that. Divide both sides by negative 1. And what happens is on the left side, the negative and negative, they cancel each other out, leaving you with m over 1, which is just m. And on the right side, negative 3 over negative 1 is positive 3. But here is where things will be different. Whenever you divide both sides of a negative number, both sides of an inequality, then the inequality flips, which means greater than or equal to switches to less than or equal to. All right, now I have one part of the solution. I got to do the same steps on this side for the second part. So let's do that. Subtract 5 from both sides. Then 5 minus 5, it's negative m, that is negative 7. Does not matter to the inequality, remains the same. Then again, let's copy that and then divide both sides by negative 1. And so this time I have m less than or equal to positive. Oh, sorry. The inequality flips this time. So m is greater than or equal to 7. Now, just like here, when you divide both sides of an inequality by a negative number, the inequality flips. Less than or equal to becomes greater than or equal to. Now let's try to first draw the graph on the number line. So how does that look? You always want to write down 0 somewhere. Now what numbers do I need? I need the 3, which is on the right side of 3, on the right side of 0. And I also need 7. And 7 is again on the right side, but further down. Now notice it's m less than or equal to 3, which means I need to go to the left of 3. So it's going like that. It keeps going to the left of 3 because it's less than or equal to, which means the boundaries are included. And m is greater than or equal to 7, which means I start at 7 and the boundary is included and shade everything to the right of 7. How do I write this using intervals? Remember, I always want to start at the left end point. So here, there's no end. So we say you start at negative infinity and go all the way to 3. Include the 3, so use brackets. And then start at 7, include 7, so brackets 7, comma, infinity. And be sure to write your union symbol for the sets. I think that should give you enough idea about how to solve absolute value inequalities. And I have some practice problems here for this particular video. And the answers will be in the video description. So there are 8 problems. Solve absolute of x greater than or equal to 7. So it's just a matter of writing the 2 parts of the solution. In 2, you would have to first get rid of the negative 3. You would first add 3 on both sides and then write down the 2 parts of the solution. For 3, you're going to divide both sides by 2. For 4, you can write down the uh, solution parts not for the variable but for z minus 3, and you keep doing that. Keep going, do number 5. On number 6, you have to divide both sides by -5 first. So it's going to flip the inequality. Now, when the inequality is flipped, notice this is no longer less than or equal to, it becomes greater than or equal to. So it's still what you learned in this part. Now, when you work on this one, absolute of 3 minus u is greater than or equal to 5. Just like problem 4, you would first write down the expression 3 minus u greater than or equal to 5, 3 minus u less than or equal to -5, and solve for u. But whenever you divide both sides of an inequality by a negative number, be sure to flip your inequality. And the same thing happens on number 8, but this time you have to divide. You'll have to divide somewhere by -5. So again, the inequality flips. So that's all I have for this video, and good luck. I'll see you in the next video. The next video will combine both parts 1 and 2, and we will look at some trick questions. Not trick, but some other kind of solutions where the solution is the entire number line or there is no solution. All right, I'll see you in the next video. Bye-bye. Thank you.